Hi everyone, this is Raju from Smart AI Technologies. Today we'll take a topic called pneumonia detection using deep learning model. First we'll see what is pneumonia and why we need to do our deep learning model for detecting the pneumonia and how we are doing that. First of all, pneumonia is a disease which actually affect the lungs just like COVID. It means they're gonna attack the cells of lungs and they're gonna fill it with water. So we call that process as like that. That is known as a pneumonia. Okay. So there a person who is if affected by that pneumonia virus will unable to take breath and it may cause death or some serious injury to his lungs. Okay, this is about the disease and why we need to use deep learning model to do that. The thing is that all these inner organ related diseases, it's very hard to predict. Even we get some scanned images, maybe you will get MRI scanned images, maybe if you can get CT scan images, any type of scan images you will get. It's very hard for doctor to recognize particular area for treatment, particular area for the decision. Why? Because that disease on the images will sometimes be mimicking it. It will not be real, it will be some other infected part or like that. Okay, so in our case here we have four classes, that is lung opacity, normal type of lungs and viral pneumonia lungs, and the fourth one is COVID. Even we have images of COVID affected lungs. So here we are trying to classify four types, that scanned image into four types. Like what is the status of that lung scan image. So let us move on and I will be explaining you the whole code line by line. First we will check the data set. This is our data set. Here we have four subfolders. Among them, first one COVID will check. Okay, you can see under COVID what is the status of image, how image looks like. I'm just showing you some of the images. Okay, and after that the next one is lung opacity. You can see how when a person is affected with lung opacity, how the lungs images will be. Okay, then we'll check with some normal images, normal lung images without affected or infected with any viruses. Okay, it will be very bright and it will not be having any dots anywhere. So it's very hard for doctors to classify like these four classes. You can only say okay, it's affected, it's unaffected very easily. But when you need to take decision whether it's affected with COVID or viral pneumonia or lung opacity like that, no, it's very hard for doctors to decide. For that, if we have one proper model with which actually works with more accuracy to give a result, it will be far better. So that's what we are doing here. So try to watch it completely. Here we'll be following some steps, they may help you to do some other projects also. In further videos I will be taking some other more interesting topics related to agriculture, health or defense or like that. Okay, you can just message whatever the topic you want. Based on that we will be making deep learning or machine learning projects, so they may be helpful for you. Otherwise you can message your own topic on which we need to make a video. It will be very helpful for you also. So let us start with the code. First I am going to import OS and globe. OS is library that is used to work with operating system, like accessing the folders and accessing camera or like that, operating system related tools. After that we are going to import globe. Globe is a library which we use to import subfolders. For example, in my dataset folder I have four subfolders. Within them there are some images. Now if I want to access inner content of all subfolders, all classes, That is nothing but if I want to access all the image paths of this COVID images of the COVID, okay, I can access it using glob. That I will show you how we can do that. Then we are going with NumPy. NumPy is actually used to work with arrays and matrices. Seaborn is used to plot some good visual graphs, and then comes Matplotlib. Matplotlib is actually used to plot the graphs and also to display the images. Then comes Pandas. Pandas is actually used to import data sets which are in text format, CSV format or Excel sheets. Or you can create data frames which you can save it as CSV, Excel or TXT files. You can do it in either way. For that we use Pandas. Then I'm going to use scikit-learn model selection. From scikit-learn model selection, I'm going to import a model function named train test split. This is used to split the data into train, test and validation. And then comes image data generator, which I am importing it from Keras. This is used to augment the data before pushing it to model. You can augment the data here itself, and you can pre-process the images using image data generator. And then comes the model. Model is function which is used to bundle up all the layers and create a model. Now whatever the below libraries are there, like convolution 2D, maxpool 2D, flatten, dense and dropout, these are all deep learning layers. They will be having their own functions. Layers nothing but they will be having a logic which works with, like for example, convolution 2D, maxpool 2D, flatten. I will give example as a flatten. Particularly flatten will reduce multi-dimensional matrices into one dimensional matrix. Okay, dense will reduce multiple results into our required result based on our requirement. For example, if I am getting 10 inputs, if I need 2 outputs from those 10 inputs, if then dense layer is used, dense will reduce the input and give the output how many I want. Dropout layers is actually used to consider most important inputs to drop unwanted inputs in the layers. So it will reduce the time of model training, and it will increase the accuracy. Dropout, that is a positive view from the dropout library, the dropout function that you can use. And there comes callback and early stopping. Why we need callback and early stopping, I will explain in the next ongoing video. Like when I come to model building, I will explain that, so try to watch it clearly. Then comes RESNET50. In this model we are using RESNET50 as our deep learning model. We call this process as transfer learning. What is transfer learning? Transfer learning is the process of training a model for our purpose which is already trained on some other particular data. It is like training a karate boy for a kung fu. It means he already knows something in martial art. You are training it for some other martial art using his old knowledge of karate, like that. Okay, I will explain in depth about these things. And then comes pre-process input. Pre-process input is default is having some augmentation parameters, like what is the rotation it should be, what is the zoom size it should be, what is the size of image, like that. Okay, we can this is pre-process input is already predefined. Otherwise you can make your own augmentation parameters. I will let you know in the next part of this video. It means in the next during model building. And after that, finally I am using a library called classification report. This library is used to get complete report of the model, whatever the model that we are using to build and to train. We'll see here only, we'll see all the output parameters of confusion matrix, F1 score, recall score and all those stuff. So let us start with our data set. First I am getting path of the data set, then I am taking list of the directories, whatever the subfolders I have lung opacity, normal, viral, pneumonia and COVID. and after that what I am doing is I am getting list of all the image paths, from dataset, lung opacity.png, like this. From all the subfolders, from four subfolders, I am getting all the image paths into file path. Then in the next part, what I am doing is I am getting from the above paths, I am extracting second part of it, lung opacity, and some it will be COVID or like that. Second part. What is this second part mentioned? Second part is the name of the subfolder, that means the name of the class, that is the label what we say. This images belongs to lung opacity. Okay, then it will be lung opacity here. Like this I made two lists now. One list is having complete path of all the images, second one is having complete label name of all the images. Now taking both of them, I am going to create data frame here. After creating data frame, you can see one column I gave it for image path, and second path I gave it for label, particular label. Then I am just trying to print how many images I have in each class. Almost the data is balanced, but in one of the folder it's 2500, but in all of them it's 3000 images for each class. So we have good data set. Then we need to split this data for training and testing. What is the training and testing split? Actually, I will go with an example. Now there is a small boy, you are told to train it for 10 fruits. Now what you will do, you will take 3 fruits out, you will keep 7 fruits, you will teach him about 7 fruits, he will learn about that. And when he learned well about 7 fruits, finally what you will do, you will take out those 3 fruits, whichever you kept outside, and you will ask him what is this fruit. He will predict something and you will say. Now you will verify, okay, how well he trained. Okay, this is a situation. Here whatever the 7 inputs you used, that is training input. Whatever the label you told during training, okay, this is apple, this is like that, you will be telling him during training, that is training output. Now when you are doing testing, you are taking those 3 fruits which are kept outside, that is testing input, and whatever he is predicting it for testing input is a prediction. Okay, now in our case, out of 10 fruits we split 7 for training and 3 for testing, that is 70-30. Here if I need to split my data into 25 into 75, I need to give test as 0.25. It means 25% I am going to use for test, 75% I am going to use for training. Why this random state? What is the importance of this random state is that when I use random state 42, I will mix up the rows. Sometimes what happens is sometimes data frame is created like, okay, first complete rows are lung opacity, next viral pneumonia, like that. While I am splitting the data, below splitted rows will be only one class. It should not happen like that. So it should be mixed up. So for that we use random state to mix up the data. Then I am just printing or just showing, I'm just showing some images from each class. You can see how they are. And then comes image data generator. Here one thing you keep in mind, whatever the data we have, everything should be converted into arrays or matrices in the end. Maybe you have image, maybe you have any text or like that. But in our case, till now we have images, only images. We didn't apply any pre-processing on it. We need to pre-process those images. For that what I am using, actually I am using pre-process input from RESNET50, which I mentioned above. Instead of that you can use image data generator is a library which is used to pre-process the image. For example, I will take you to the its website. Image data generator, you can see here there are so many options for you. These many options are there, but here what I am doing is, as I am going with RESNET50, for RESNET50 there are some predefined well suited pre-processing informations, like among these maybe this may be rotation maybe 30%, width shift maybe 0.1, like that. They are already pre-processed and they are kept under pre-processed input function. I'm calling that directly. Otherwise you can directly take any of them. Okay, you can select all the features and you can make the changes according to the explanation given here. Okay, you can play with all the features here. Okay, you can replace them here, image data gen data. Once you replace them here, what will happen is on each image everything will be applied. For example, in our case, okay, first what it will do is rotation range. If you give 20%, image will rotate 20%. If I have one image, it will be rotated into 20% and it will be fed to deep learning model. What is the importance of this image data generator and augmentation? Here, for that I made a video, like what is the importance of augmentation in deep learning. I made a video, you can check that, okay, from our channel, but I will keep it very short here. Okay, for example, while you were I will take one real example which I already given you. In that case, if you show an apple to a boy, you will learn from one side, and if you test him again with some apple rotated, you may get confused. So in case while you are training, you need to move that apple in all the angles in rotations, and you take it away and near to him. You need to cut that into some parts and you need to show him like that. That is augmentation. It means changing the rotation angles, zoom, or like the shifting. You do and train the model, it will train it very well. Then here I am just taking it as a function, data gen, but I need to apply this function all over to my data frame. That I am doing here. To train, which I defined above, I am applying train data gen. Okay, to test data set, I am again applying test data gen here. To train data gen, test data gen. It means now I am taking all the images and I am converting them into arrays after augmenting them. Now they will be in array format. Till now whatever we did pre-processing of the data. Now we need to go for model building. As I mentioned you, we are going with transfer learning of RESNET50, and I already told you what is transfer learning. Transfer learning nothing but, for example, in our case RESNET50, this is trained for 1000 classes of images called ImageNet dataset. That is trained for long time. Okay, now this RESNET50 will know about 1000 classes. If you show anything from 1000 classes, maybe chair, table, like that, if you show anything, it will say okay, this is chair, this is table, with more than 95-96 accuracy, like that. That RESNET50. But now we need to use that for our purpose. How we will do it? Initially we will take that, and that RESNET50 was trained on size of image 256 cross 256 cross 3, but in our case our images are 100-103. That I need to replace. I am changing that here, and I am saying include top false. It means I am saying okay, whatever you already learned, that's fine, but now you don't consider the previous data, consider this data 100-103. okay, use ImageNet. Wait, nothing but you like use the information which you got trained for ImageNet. Okay, like that I'm telling that model. Once I get that pre-trained model, so it was trained for 1000 classes. Now whatever you show, it will try to predict in 1000 classes, but I don't want that. I want that to classify in 4 classes, that is lung opacity, normal, COVID and pneumonia. Okay, I need to mention it. Whatever the data in middle happens, finally I want only 4 results out of that model. That we call it dense. Once I get, my model building will be complete here. Then I need to compile it. Here you need to mention what is the optimizer that you are going to use. What type of loss? Categorical loss I am giving. Why? Because I have 4 categories. If I have only 2 categories, I can give binary loss, and metrics you can we are using accuracy. Okay, whatever the things you will mention here, loss or metrics. Okay, some people will try to get categorical loss. Okay, categorical cross entropy as a loss, or in accuracy also categorical wise accuracy can be printed. Okay, here in the results you can see validation accuracy and validation loss will come, and accuracy will come, and loss will come. it will be because of this compiling. Okay, whatever you will mention in compiling, that will be printed out. Now there I made a callback function. What is the need of callback function? So here I am mentioning, if my validation accuracy is not improving after 2 epochs, let us stop there. If I gave 100 epochs here, but after 20th epoch my validation accuracy is not increasing, then it will stop training there itself and it will save the model. It will not move further, because that is the waste of time. If something validation accuracy is not improving at all, you need, if you train it for 100 epochs, then there is no any importance of that. That is just waste of time. That's what this early stopping will do. But there is also one drawback with it. Sometimes what happens, all the models will not be linearly increasing. Some models will increase, drop and increase. In that case, callback function will be like it will be a negative thing for us. In that case, it will stop in middle itself. In my case, it ran for 10 epochs because it need to run for minimum 50 epochs or 100 epochs to get better accuracy. For 10 epochs itself, we are getting so much good accuracy. Validation accuracy is 93 and training accuracy is 98. If you train it for 50 epochs, you will get good accuracy. You'll get like nearly validation accuracy will be 98 or like that. So then I'm going to save that model. Okay, this fit here only you can mention how many epochs you want to train. What are these epochs? Nothing but epochs are nothing but, for example, I will take that old situation which I explained now. While you were training a boy, you trained using 7 fruits. First time you trained using 7 fruits, you learned something. Again you used 7 fruits, again you trained him. Again you used same 7 fruits and train him. You done it for 10 times. That means epochs are 10. It means the repetition of giving input for a model to train, we call it as an epoch. That the repetition, how many times we need to train that model. The more times you train, the better the accuracy. So then I will save that model using model.save. Then I'm going to plot the loss and accuracy. You can see here, actually the graph is cropped graph. Okay, that's why you feel like lines are away from each other. But you can see on y-axis it's 0.84, from 0.84 to 0.98. Okay, it means the validation accuracy and test accuracy, real training accuracy are very near, and loss also the same. It's almost very near to each other. Then I am validating it using some data. So now when I do the validation is also 93.85. Now I need to get the report. What type of report I will get? That is classification report. It will give precision score, recall score, reference score and support. If you want to know much about all these 4 parameters, how we will get it from confusion matrix, I will be making a video. Otherwise you can directly contact us. I will be giving you information, because this is itself another concept where it comes under confusion matrix and analyzing the confusion matrix using some equations. They are all equations, set of equations. Then I am going to use that model and I am going to predict on some images, and I am going to compare it with my true values. Here you can see true, it was lung opacity. My model predicted lung opacity. True was viral pneumonia, predicted was viral pneumonia. Like this you can see. If there are any error, I don't think, because model is working very well, so we are not getting any error. Our model is very perfect in predicting it. Here I am giving COVID image as an input. Okay, that image I will show you which image I am feeding. Yeah, this one, covid2.png. It means this is a COVID image and I am feeding, I am asking, okay, first value is 99. It means in our folder, when I see data set, what is my first folder? COVID. It means this is the first one. That means class is predicted properly. Same thing we will check with lung opacity once. Let us see what happens. We will take its name. We'll replace it here. Control. This is a lung opacity.png. Okay, lung opacity is our second class, that is it is also predicted properly. Then we will go for viral pneumonia. Okay, initially I took first image, we will drag down randomly and we'll take some random image. I'll say I'll take this viral pneumonia, I'll paste it here, I'll take its name. Okay, I'll paste it here. It says 98% it belongs to fourth class. What is the fourth class? Fourth class is viral pneumonia. It is bit confused. 1% it have confusion that okay it is COVID. Why? Because viral pneumonia and COVID are almost having the same type of cause on the lungs. So it is getting a bit disturbed there, bit confused there. But it's fine. 98% it is saying viral pneumonia. Only 1% we are getting disturbance. If you train it for more than 50 epoch or 100 epochs, nearly 100 epochs, you may get better accuracy and model will be working very perfectly. And if you want us to help you, we will be helping you. Okay, you can directly contact us in the case. And the thing is, we will be posting so many other videos which will be very helpful for you. Try to subscribe and like our video, and also try to click on that bell icon button where you will be getting notifications whenever we will post some videos. They will be helpful for you to prepare, or it will be helpful for you to make different projects. Okay, thank you very much for your time and patience. We'll see you in next video.